Welcome to World Action and Reaction News. Before starting today's news, my request to all dear friends, please press like button if this information is useful for you, and also hit the subscribe button along with bell icon for future news updates. Let's start today's news. On January 17, 2015, the then Defense Minister, Manohar Parikkar, handed over the first series production Tejas Light Combat Aircraft, LCA, to the Indian Air Force, IAF. Aeronautical Development Agency, ADA, designed, Hindustan Aeronautics Ltd, HAL, manufactured, multi-role, single-engine, tailless Delta. The LCA Mk I was in a pre-initial operational clearance, IOC, status. This was more of a ceremonial handover, and the real battle-ready aircraft with final operational clearance, FOC, would come much later. Nearly 18 months later, on July 1, 2016, the IAF's first Tejas squadron was formed with just 2 aircraft at Bengaluru. HAL handed over the 2 aircraft to No. 45 Squadron Flying Daggers at a much-hyped ceremony, rightly preceded by interfaith prayers. Bengaluru was chosen for temporary location of the squadron to cater for the initial technical glitches that could be experienced and product support from HAL. Also, the IAF's Flight Test Center, Aircraft and Systems Testing Establishment, ASTE, is located next door. More importantly, large part of maintenance and operational documentation was still evolving. Physically, the aircraft may move to the designated IAF base at Sulur near Coimbatore in 2018. The long arduous wait for the aircraft is still not over for the IAF. This compound Delta platform is designed with relaxed static stability for enhanced maneuverability. Originally intended to serve as air superiority aircraft, it has a secondary ground attack role. The wing and fin are made of carbon fiber reinforced polymer. It is one of the smallest and lightest fighter aircraft of its class in the world. The IAF requires 200 single-seat and 20 twin-seat aircraft to replace its aging MiG-21 fleet, and Indian Navy, requires 40 for carrier operations to replace Harriers. This Rs 200 crore aircraft was to originally enter service around 1995. However, the LCA undertook its maiden flight on January 4, 2001. Delays to operationalize the Tejas forced the IAF to extend its older fleet of aircraft, with the inevitable security and flight safety implications. Technological development. After a very bold but not fully successful attempt with the HF-24 Meerut in 1960s-70s, 147 of which were inducted into the IAF, HAL began studies on a tactical air support aircraft. However, it could not find a suitable engine, and also by 1975, the IAF was actually looking for an air superiority aircraft with secondary ground attack role. By 1983, the IAF had clarified that the new aircraft would be a replacement for MiG-21, which constituted 40% of the IAF and were to be phased out in 1995. The IAF finalized the service qualification requirements, SQR, in 1985. To better coordinate and build core state-of-the-art aerospace technologies, ADA was formed in 1984 to manage the design and development program of the now designated LCA. Though HAL was to finally manufacture and deliver the system to the IAF, the ADA, with a consortium of defense labs and industries, was to prove the aircraft. In this process, India did master technologies related to the glass cockpit architecture and the carbon fiber composites developed by National Aerospace Laboratory, NAL. The areas of real challenge were turbofan engine, pulsed Doppler radar, and fly-by-wire flight controls, for which even today India remains dependent on foreign firms. The Martin Baker ejection seat is also imported. Nearly 70% of aircraft components are reportedly manufactured in India, but with the engine, radar, and some avionics including electronic warfare suite imported, it has its Achilles heels. HAL and the Electronics and Radar Development Establishment, LRDE, have not been able to produce viable multi-mode radar, MMR, efforts for which began in 1997. By 2006, it was clear that the MMR was experiencing major delays. Besides, cost escalation and the performance of several modes fell short of expectations. Acquisition of an off-the-shelf foreign radar as an interim option was exercised. Similarly, the GTRE responsible for the development of the Kaveri engine had not seen success. The Kaveri engine program was launched in 1986. The development moved with serious hiccups at all stages. At an early stage, it was decided to fly the LCA with a proven engine, and General Electric, GE, F404 GE F2J3 was selected. Finally, in 2003, the upgraded variant F404 GE in 20 was mounted on the series production aircraft. In mid-2004, the Kaveri engine failed its high-altitude tests in Russia, ending the last hopes of it powering the Tejas. In 2006, help of French aircraft engine manufacturer SNECMA was sought to recover the Kaveri engine, but by 2008, it was clear that the Kaveri would not power the Tejas and was delinked in 2008. On November 20, 2016, DRDO announced that it had tied up with SNECMA to revive the Kaveri engine project as part of the offsets deal for 36 Rafale aircraft. They hoped the engine would be integrated and tested on the LCA Tejas by 2018. High-speed powerful control actuators still come from abroad, though work on its development is in progress in India. Fine-tuning of the control laws for this relaxed static stability aircraft was a massive time-consuming task. The support from Lockheed Martin was terminated after 1998 after the embargo was imposed by the US. The task was then taken on by NAL. The automatic flight control system as it finally evolved has been highly praised by all the test pilots associates with the Tejas project. Major milestones: the original schedule called for first flight in April 1990 and service entry in 1995. The tailless delta wing design was frozen in 1990. The proof of concept phase, which included the design, development and testing of two technology demonstrator, TD1 and TD2, aircraft, began in April 1993 and was completed in March 2004. During design and development, the higher-than-planned aircraft weight had reduced the thrust-weight ratio with existing F404 engine. It affected the aircraft performance, including sustained turning rate, maximum speeds at low altitudes, angle of attack range, and weapon delivery profiles. The GE F414 was chosen as replacement. The new engine is larger and heavier and will require major changes in intake size and affect weight and CG dynamics. The LCA Mk II with the new engine will effectively be a new aircraft requiring considerable fresh testing. The IAF initially placed orders for 40 aircraft with the F404 GE in 20 engine. The trainer variant prototype flew first in November 2009. In April 2010, the third production aircraft, LSP-3, flew with a hybrid version of the ELTA-L/M2032 multi-mode radar. The weapon tests, including bombing, begun in September 2011 at Pokhran range, to be followed by missile firing tests at Goa. Rafale's Derby Fire and Forget missile will serve as the Tejas' initial medium-range air-to-air armament. Tejas has completed precision bombing with laser-guided 1,000-pound bombs and unguided bombs. On November 8, 2014, the trainer variant PV-6 took to the skies. In December 2014, the LCA Navy successfully conducted shore-based ski jump trials at Goa. The aircraft can now carry close to 3 tons of weapons, which include laser-guided 500 kg bombs and short-range R-73 missile. It can reach top speeds of 1,350 kmph, pull up to 7 grams and reach an angle of attack of 24 degrees. Cost of the IOC aircraft variant is around Rs 180 crore. FOC of the Tejas is held up due not only to its performance specifications but also incomplete flight envelope to meet service requirements. What ails the program? Launching the LCA was a major technological jump for India, and some amount of delays were bound to be there. The ADA has often blamed the IAF on frequent SQR changes. This is far from the truth. An aircraft, which was scheduled to be delivered in 1995, is still crawling towards induction in 2017. The user can normally not freeze SQRs forever. IAF sources insist the SQRs have if at all been only diluted to accommodate delays and lack of capability. For long, the critical systems sale embargo after the 1998 nuclear tests has been used as an alibi to cover up developmental delays. Undoubtedly, some small delays were introduced by the embargoes. On many occasions, the technical problems were staring into our face, but calls to take outside help were delayed unduly. The Kaveri engine and MMR projects were case in point. Historically, the DRDO has made over-ambitious and unrealistic commitments including timelines so that it did not lose the project and the allocation of funds. The DRDO structure is such that the management grows from within through seniority. Most laboratory directors are in their late 50s and often with very short tenures and incapable of meaningful policy changes. Air Commodore K.A. Mathana, the then project director flight testing, had candidly summed up in a paper published in October 2014, that the legacy of this aircraft's development had been a challenge at every stage. This fine aircraft had been hostage to a series of systemic shortcomings. The program has been steered in parallel at three levels: fighter pilots of the IAF, bureaucrats of the Ministry of Defense, MOD, and technocrats, ASTE, HAL. Coordination was often lacking. The SQRs were beautifully drafted and well ahead of time and based on US standards. Two design agencies, ASTE and HAL, had their own organization-specific outward-facing poles. The responsibility for post-deployment, maintenance of documentation, software, and their periodic upgrade remained vague for long. The IAF is the only repository of comprehensive military aviation knowledge in the country, yet its expertise was taken only in small bits. As a result, while the designers concentrated on getting the technology airborne, the design necessities of turning the aircraft into a maintainable, deployable and employable weapon platform were missed to a large extent. Excessive concentration on basic platform design and lack of attention to avionics had resulted in patch repair modules. Lack of operational expertise in design teams led to replicating the Mirage cockpit logic on the aircraft without exploiting the significantly advanced hardware architecture of the Tejas. Transition from design to manufacture is a complex process that requires to be handled carefully. Correct manufacturing tolerances are important for quality of end product. Concurrent development of support systems such as tools, testers, and ground equipment, TTGE, was vital to deploy the aircraft quickly. Flight and maintenance simulators are important for training. Their development has been unduly delayed. Yet the Tejas is a wonderful flying machine. It deserved to be in squadron service years ago. Remedial action on many of the shortcomings will favorably impact the end product, Air CMDE Mathana concludes. CAG Report, A Controller and Auditor General of India, CAG, Report of 2015 commented, LCA Mk I, which achieved initial operational clearance in December 2013, had significant shortfalls to the tune of 53 permanent waivers/concessions in meeting air staff requirements, ASR, as a result of which it will have reduced operational capability. Listing the shortcomings, the CAG said that the LCA Mk I failed to meet the electronic warfare capabilities sought by the IAF, as the self-protection jammer could not be fitted on the aircraft due to space constraints. Also, the radar warning receiver/countermeasure dispensing system fitted on the aircraft had performance concerns. The shortcomings in the Mk I included increased weight, reduced internal fuel capacity, non-compliance of fuel system protection, pilot protection from front and reduced speed, are all expected to be overcome in the Mk II model. The ASR deficiencies were now expected to be met in LCA Mk II by December 2018, the report said. While DRDO had always showcased LCA as an indigenously developed aircraft with indigenous content of 70%, or it actually was about 35% as of January 2015. Systems taken up for indigenous development such as the engine, multimode radar, radome, multifunctional display system and flight control system actuators taken up for indigenous development did not fructify, resulting in LCA's continued dependence on foreign manufacturers. Talking about lack of trainer aircraft, the CAG said that the IAF was in the interim, using an upgraded full mission simulator, FMS, at ADA for pilot training, pending supply of an FMS by HAL at the LCA operating base. Long gestation period forced change of weapon systems on the LCA, necessitating acquisition of new ones. It also led to design changes on the aircraft, coupled with delay in integrating R-73E missile with the radar and HDMS. Delayed identification, December 2009, of beyond visual range missiles also contributed to the delays in achieving IOC/FOC. The CAG said that the manufacturing facilities at HAL cater presently to only 4 aircraft per annum as against the envisaged requirement of 8 due to delays in procuring plant and machinery, tools, and also construction of production hangars. Criticism of the Tejas was unfounded, say DRDO officials. The Tejas has had an outstanding safety record with no accident till date. Tejas Mk II and III. The Tejas Mk II will have the more powerful GE F414 GE in 6 engine with 98 knots thrust and refined aerodynamics. It will also incorporate some 5th-generation features imbibed from the FGFA and AMCA programs. The Tejas Mk II at 14.2 m will be a meter longer, incorporating a stretched nose section and a modified fuselage section aft of the cockpit for housing an expanded complement of mission avionics LRUs. Its height will be 4.6 meter as opposed to 4.4 meter of the Tejas Mk I, to accommodate an enlarged vertical tail section. External stores capacity will be boosted to 5,000 kg as opposed to 4,000 kg for the Tejas Mk I. The 2 air intake ducts will be minimally enlarged to cater to the increased airflow requirements of the F414 engine. The IAF is committed to procuring an initial 83 Tejas Mk and the Indian Navy has expressed its firm requirement for 46 LCA Mk II, Navy. The Mk II may feature indigenously developed AESA fire control radar named UTOM. The Mk II will also see the incorporation of a new electronic warfare suite which is being jointly developed with Israel. The Mk II is scheduled for flight testing by 2018. But this may be delayed by 2 or 3 years to allow time to engineer the installation of the GE 414 engine. The Tejas Mk II is a new aircraft and will require extensive testing. Initial batch of F414 engines will be supplied directly by GE and the remainder is to be manufactured in India under a technology transfer. To obtain FOC, Derby, and Python BVR missiles and GSH-23 gun would have to be integrated. The limit angle of attack will increase from 24 to 28 degrees, the braking system will be enhanced and the existing nose cone radome will be replaced by a quartz model in a bid to increase the current radar range of 50 km to over 80 km. The aircraft will also be fitted with improved radar to give it the capability to take on BVR targets. Currently, a hybrid version of the Israeli L/M2032 radar with a range of 150 km is on board the LCA. The IAF wants AESA radar to fire long-range BVR missiles. The development of AESA radar is expected to begin after selection of a partner between the short-listed European Airbus Defence and Space and Israel's ELTA. The Electronic Warfare (EU) suite is being developed by the Defense Avionics Research Establishment, DARE. Called Mayavi, it includes a radar warning receiver, RWR, missile approach warning, MA, and a laser warning receiver, LWR, system. It also will have infrared and ultraviolet missile warning sensors, self-protection jammer, chaff and flares dispenser, and electronic countermeasures, ECM, suite and a towed radar decoy, TRD. It could take few more years to develop all these. In the interim, a few EU suites had been purchased from Israel's Elisra. In view of acute shortage of onboard space, the Tejas will have pod systems that will include an infrared search and tracking, IRST, sensor, FLIR targeting pod, ECM pods, flares/infrared decoys dispenser pod and chaff pod, EO/IR sensor pod and lightning targeting pods. The LCA has been over 30 years in the making, but it will be at least another 5 years before the Tejas Mk II will be available to the IAF with FOC. The Tejas Mk III is planned to be stealthier than Mark II and have composite usage up to 70%. Also, it is expected to have reduced infrared signature. JF-17 vs LCA Mk I, with China and India emerging as global powers, comparisons are being drawn between the JF-17 Thunder and LCA Mk I. Both Indian and Chinese for Pakistan projects are meant to replace similar vintage aircraft and give boost to indigenous capability. Both have had to use a foreign engine and airborne radar. The JF-17 SRD-93 engine availability and reliability is low, and the Chinese radar is of lower technology. Comparisons are flawed. While JF-17 will be Pakistan's main fighter, accompanied by the upgraded F-16S, Mk-52+, Chengdu FC-20 and possibly Sukhoi Su-35 if offered, whereas LCA Tejas will be India's additional aircraft for medium-role combat missions after Su-30 Mk I, MiG-29, Mirage 2000, Rafale, FGFA and under development AMCA. The Tejas uses several new technologies such as composite materials, advanced avionics, and a unique aerodynamic configuration, and has good potential to be expanded into variants. Nearly 90 JF-17 aircraft are already in service with the Pakistan Air Force and have logged over 20,000 hours of flying, including operations in the Northwest. It is a good contender for low-cost, third-generation aircraft, ideal for classic Russian MiG-21 budget militaries. Myanmar and Nigeria have already placed orders 16 and 3 aircraft respectively. China is helping market it to some other smaller countries. The LCA is at least 5 years behind in operational usage. The unit cost of the JF-17 is $15 to $20 million vis-a-vis the LCA's $25 million. Miles to go. As things stand, the IAF will not see a full squadron of Tejas Mk I operational until 2019, while the first operational Tejas Mk II squadron is at least a decade away. The Navy LCA Mk I aircraft are scheduled for completion by 2020/2021. An interim variant evolved by HAL is the LCA Mk I-A, which will have the improved version of the Israeli L/M2052 AESA radar and an electro-optic EO suite. It will also incorporate weight reduction along with easier servicing and maintainability, and have a mid-air refueling probe. The IAF has placed orders for 83 LCA Mk I-A. Induction of this variant will begin in 2020. 4 squadrons of the LCA Mk II are planned. It is unlikely to be ready induction before 2024. Finally, the IAF requires 14 LCA squadrons with 294 aircraft, including 2-seaters, to replace the MiG-21s. 6 LCA squadrons are expected by 2024. The IAF should have around 100 LCAs in Mk I-A standard and another 80 in Mk II standard flying in 2030. The IN has expressed its firm requirement for 46 LCA Mk II, Navy. The current rate of LCA production by HAL is still at 8 aircraft per year. It is proposed to increase the annual production rate to 16 by 2019. All this indicates that there is a long way to go. A stealthier LCA Mk III is still a distant dream. The fact that the MOD is already talking of a Make in India single-engine fighter, indicates that the IAF is looking for something of a better class than the LCA to fill the gap. Success of the LCA is of great national importance. The IAF waits with fingers crossed. Thanks for watching. I hope you like this news. Please share your views in comment box. Please like and share this video. Press subscribe button and bell for auto update to you regarding my channel World Action and Reaction News. Warn.